Hello, welcome to this new channel Metasonic Bangladesh. This is the new series Electrical Engineering. Here we'll learn something about series and parallel combinations in the lecture 1. Just because this is a new series of electrical engineering, this will help students of electrical engineering or computer science and engineering a lot. Basically, I upload videos for HSC level students, but I think I should upload more videos on electrical engineering or something like that. So in this first lecture, we'll learn about series and parallel combinations. So to do so, we need to know what is series and parallel combination. For that, so just think about series combination. So what is? Suppose we have couple of resistors. So before that, we need to draw a resistors. In our textbook or in our examination paper, we draw resistors like that. So this is actually a resistor. Okay, I will remove that. So in series combination, the resistors are like that. Suppose there are two resistors. One is R1 and another is R2. If before that, we need to know that each resistor has two leads or two terminals. So let me color. So this is the blue terminals of R1 resistors and the green terminals are for the R2 resistors. Okay, I will remove the color now right now. So now if I connect the terminal on the right side of R1 and terminal of the left side of R2 together simply like that, then this kind of combination is known as series combination. So this is the common terminal or common point between R1 and R2. If this happens and so on, there are most probably more than two resistors like that. There are R3 or something like that. So for two resistors, there is a common connecting point or common what I can say terminals. There is common terminals for two resistors. So this kind of combination is basically known as series combinations. There can be a voltage source. Suppose this is, sorry, it should be large, this is V. This is connected to all these resistors in series. So basically the direction of current is from the positive terminal to the negative terminal. This is the conventional law, so we use that. So let me decide that, or let us decide that the current is I. So the current I flows through R1, R2, R3. The current doesn't divide because there is only a single path. There is no multiple paths. So current needs path to divide. So in that case, there is only a single path like that. This is a single path from R1 to R2 to R3 and to the negative terminal of the source. So current doesn't divide. But for voltages or potential difference, we need terminals. So for R1, there are actually two terminals. Let me color it green. For R2, the terminals are red, or for R3 the terminals are suppose green. So for each resistors there are different terminals. As there are different terminals, the voltage should be divided. Okay, to calculate voltages, suppose this is another circuit, different circuit. Suppose this resistors is R or something like that, Ri, and there is a voltage source V. So to calculate the potential difference between the two terminals of Ri, so one terminal is this and another terminal is this. So we should put a multimeter or voltmeter to calculate the potential difference between its two terminals. So let the voltmeter is situated like that or placed like that. So we will have the potential difference or the voltages across or voltage drop across Ri in that manner. So for in series combination, each resistor, suppose R1, R2 and R3, all of these resistors have different terminals. So we can put different voltmeter. So that means the voltage gets divided in series combination. Now we are heading towards parallel combination. So what is parallel combination is? Suppose this is our resistors R1, this is another resistor R2, and this is another resistor what I say R3. So these terminals are on the right side and these terminals are on the left side. If all the terminals or the leads of the right side are connected together in that manner, and all the terminals or leads are connected on the left side connected together in such a manner, So this kind of combination is basically known as parallel combination. So there can be a voltage source. Okay, my drawing is not so very good on graphic tablet. So this is V and this is plus and this is minus, and let us consider that the current is I and current is flowing from plus to minus. So okay, so for R1 let us decide the terminals, or let us determine the terminals. For R1 the terminals are uh, yes, the blue terminals are for R1, but in that case for R2 the two terminals are the same as the R1 has. For R3 it is these terminals are also same. So in parallel combinations the terminal of all the resistors are same. So in that case if we put a voltmeter or multimeter, we have only two terminals. In parallel combination the terminals are common. So if we put a voltmeter, we will basically get potential difference between two terminals. But in this case, in parallel combinations the two terminals are same for all the resistors. That means the potential difference are same for each resistors. So in parallel combination voltage doesn't get divided. But in that case, suppose the current is flowing through this line and the current let me change the color, the current I reaches here. Okay, but in that position the current I gets confused whether to go, because there are multiple paths. A path is going from that, there is another path and there is another path. So where will current go? So some portion of the current I will go through R1, go through that line, and some portion of current I will flow or will go through that line, I mean to say through R2, and some portion of I will go or flow through R3. So let us consider that the current flowing through R1 is I1. The current flows through R2 is basically I2, and the current flows through R3 is basically or we determine this is as I3. So there are three currents. So in parallel combination what we have learned that the current gets divided. Okay, so but in the last terminal, just consider that this is the first terminal and this is the last terminal. In the last terminal we'll get the total current back. Suppose I equals I1 plus I2 plus I3. Okay, so in basic sense we can write 4 equals 3 plus 1, or 4 equals 2 plus 1 plus 1. So if 4 is like I, so 2 is like I1, 1 is like I2, and I3 is like 1. So in that sense we can write that from first terminal the current gets divided and the last terminal will get the total current back. But in series circuits we know that the voltage gets divided. So in the similar way we can write that V equals, suppose for R1 the voltage is voltage across R1 is V1, the voltage across R2 is V2, and the voltage across the terminals of R3 is V3. So we can write V is equal to V1 plus V2 plus V3. So we can write these equations. Okay, so in series circuits the current actually doesn't divide but the voltage divides. But in parallel combination or parallel circuits the current actually divides but the voltage remains the same. So this is the basic concept of series and parallel combination. In the next video we will be learning about the equivalent resistance or how to calculate the equivalent resistance of series combination or parallel combinations. So that's it. That's it. This is the first ever video. Thumbs up if you like, or if you have any kind of questions please comment below and subscribe our channel.